So let's go ahead and take a look at our first problem. Let's say we have the fraction 1/3, and we want to add that to the fraction 2/6. So we have 1/3 plus 2/6. So first thing we want to do is let's try to represent this guy with our fraction model. So here we have a pizza cut into 3 pieces, and we only have one of those pieces. So this would be 1, then 2/3, then 3/3. We only have one of those pieces. And then this one is a pizza cut into 6 pieces, and we only have 2 of those pieces. So you have 1/6, 2/6, 3/6, 4/6, 5/6, 6/6, and so on. But actually, this is the amount of pizza we have, 2 out of 6 pieces. Now notice right away, before we do anything, that actually these fractions actually look like the exact same amount of pizza. Even though 1/3 and 2/6 look very different, they actually represent the same thing. Why do you think that's the case? Because if we take this, we already know we can multiply a fraction, top and bottom, by the same thing. If we multiply by 2 and multiply by 2, we'll get 2 on the top, and 2 times 3 is 6 on the bottom. So we know from equivalent fractions that we can multiply fractions by whatever we want to get the same, a new fraction with different numbers, but represents the same thing, and that's all that's happening here. So even though these look different, they actually represent the same amount of material. So of course, if we add them together, it's going to look something like this. So before we go any farther, let's just put these here and say, how will we add these? We see we have a 6 on the bottom and a 3 on the top. So if we multiply this by 2, we already said this, if we multiply this by 2, then what we're going to have is a 6 on the bottom and a 6 on the bottom. That's what we need to add these guys together. So on the top, if we say 1/3, we can multiply top and bottom by 2. By 2, what do you think we're going to get? We just said what we're going to get. 1 times 2 is 2, and 3 times 2 is 6. 2/6. It's the same thing as this, and you can see that they're the same thing because they already represent the same thing. We'll be adding this, of course, to 2/6. Now we can see it very easily when we have the models here, but you know, when we're doing problems later down the road, you're not going to draw pictures for everything, so you wouldn't know ahead of time that those represent the same thing. All you would say is, I need the same denominator, so I'm going to multiply this times 2. So that means I multiplied this also by 2, so here's my new fractions. Now I have a 6 and a 6 for the denominator, so I'll put that as a 6. I keep the 6 in the denominator, and 2 plus 2 in the numerator. 2 plus 2. So what do I get? 2 plus 2 is 4, and so I get an answer of 4/6. And I ask myself, is 4/6 fully simplified? Because this is the answer, but is it fully simplified? The answer is no. I can divide top and bottom by the number 2, because these are both even numbers. So if I go down here and simplify that result and say 4/6, I'll divide the top by 2, and I'll divide the bottom by 2. 4 divided by 2 is 2, and 6 divided by 2 is 3. So I've taken the answer I got by addition, and then I just simplify it by dividing top and bottom by 2. I could have done it over here, but I ran out of board space here. So the answer, I think, to this entire problem is 2/3. So let's, first of all, see where we end up. If we add this fraction to this one, which is exactly what we have right here, 2/6 is the same as 1/3. We already said all that stuff. If we add them together, we're claiming that we get 4/6. So let's just put this down here, 1/6, 2/6, 3/6, and 4/6, which is exactly what you expect, because if you come over here and put this like this, let me rotate this a little bit, it'll be a little easier to see it, then you can see that this fraction and this fraction do represent exactly the same thing. So 4/6. But we said that that's also equal to 2/3. So we have here 1/3, and then we have 2/3. And of course, if we align them up, you can see that that's exactly the same thing. This one covers these, and then another one covers these. So yes, 4 out of 6 pieces is the exact correct answer when we add them, but we can simplify this to 2/3, which is a simpler way of writing the exact same fractions. All right, so 2/3 is the final answer. All right, next problem. Let's say we have the fraction 1/2, and we're going to add that to the fraction 1/6. Now, before we go any further, let's, well, you know what? Let's do this one a little bit different. Let's go ahead and pretend, let's don't use the models yet. We'll use the models toward the end. We have a 2 and a 6 for the denominators. We need to have the same denominator. If we multiply this fraction times 3, 2 times 3 will be 6. It'll match this one. So what we can do is we can say, all right then, 1/2, we can multiply that fraction by 3 on the bottom, and then if we do it there, we have to do 3 on the top. So we'll have 1 times 3 is 3, and 2 times 3 is 6. So we're saying that 1/2 is equal to 3/6. Let's add that to 1/6, and let's add these fractions together. We have the same denominator now, 6, and so 6 goes on the bottom. 3 plus 1 goes on the top, and so what do we get? 4/6. Actually, turns out that we get exactly the same answer that we did in the last problem, even though the fractions look completely different. Here is 1/2 plus 1/6, and here we had 1/3 plus 2/6. The actual answer that we get once we add these fractions together is 4/6, which is exactly the same in both cases. So it's a little bit weird, actually, but let's go ahead and see, can we simplify this any further? And we already figured out in the past that we can. We can say that this is 4/6, and we can divide the top and bottom by 2, because they're both even numbers. And what do we get? We get 2/3, exactly the same as before. So let's go ahead and circle it. Now, let's take a step back and see if we can figure out why it turns out to be equal to the same thing. So in the first case, we had 1/2. 1/2 is represented by this fraction right here, right? And then 1/6 is represented by this fraction right here. So we're basically adding them together. Now we're saying that 1/2 is exactly equal to 3/6. So we can convert that 1/2 to 1/6, 2/6, 3/6, which, look at this, is exactly equal to 1/2. So it's the same amount of material, and we're adding one more 6 to it from here. So let me see if I can probably rotate this. This makes it a little easier. Put this one down here. So we're adding these together, and now they have the same denominator. So we're adding 1/6, 2/6, 3/6, and 4/6, right? And that's exactly the same thing as 2/3. So here's 1/3, here's 2/3, and so the answer that we get is exactly the same thing, 2/3. So I know it looks a little bit weird, but what we're basically starting out with is completely different looking fractions, but when we convert them and we add them together, we actually get the same amount of material. So before we end this problem, let's go back and look at the previous problem. I want you to remember what it looked like. The 1/3 from up here, we added to the 2/6, and it looked something like this. It went about this far around. Now, if we come over here and put this guy like this, and we're going to add these two fractions together, look at this, is exactly the same amount of material to start with. Let me actually pick this up and bring it over here and show you that this is exactly the same amount of material. So it doesn't look obvious at first, but when you have 1/3 of a pizza plus 2/6 of a pizza, it actually ends up being exactly the same as taking 1/2 of a pizza plus 1/6 of a pizza. So when you use the models, you can see visually that the fractions, once you add them together, should give you the same answer, but you aren't going to always be able to use models and drawings and such. What I'm trying to teach you is I'm trying to show you how to do it with math, but then prove to you that it's correct with the models. The way you do it with math, you get a common denominator, you add them, and then you simplify the result, and you can always trust that that method of doing things is always going to give you the correct answer. All right, let's take a look at problem number 3. Let's say we have 2/5, and we're going to add it to 1/10. 2/5 plus 1/10. So again, let's do the models at the end. We have a 5 and a 10 for the denominator. I know that 5 times 2 is 10, so I'm going to change the top fraction. I'm going to say 2/5. I can multiply top and bottom by whatever I want. So I'm going to multiply this times 2 and times 2. 2 times 2 is 4. 5 times 2 is 10. We're saying that 4/10 is exactly the same thing as 2/5. That's what we're saying. And then 1/10 is what we're adding it to here. So let's add these two fractions together. And then we have now the same denominator here. So we'll put a 10 as the denominator in our answer, 4 plus 1 in the numerator, which equals 4 plus 1 is 5/10. And then we ask ourselves, is this 5/10 fully simplified? Can I divide top and bottom by something that makes it simpler? And of course, you can divide by 5 because they're both, 5, 10, 15, 20. They're both divisible by 5. So we can say, well, let's take the 5/10. And we can do whatever we want to the top and the bottom as far as dividing. So we divide by 2, divide by 5. We're trying to divide by 5 here. And divide by 5, what do you get? 5 divided by 5 is 1, and 10 divided by 5 is 2. And so the answer is 1/2. So once we start with 2/5 and we add 1/10, you do all this stuff and you get down to 1/2. And it doesn't in the beginning seem like that's possible. They look so different. But let's take a second to prove to ourselves that this is right. 2/5 means we have 1/5 here and another fifth. This makes 2/5 right there. Now we're adding to that 1/10, which is 1 piece out of 10 of the pizza. I guess I can put it over here. So we're adding these two together. We're saying that 2/5 is exactly equal to 4/10 by multiplying by 2. So we're saying here's 1/10, here's 2/10, 3/10, and 4/10. And you should be able to look at this and see if I pick this up and put it on top, it's exactly the same thing. And then I'm adding to it 1/10 from here. So when I put these pieces of the puzzle together, or the pizza together, I get 5/10 as the answer. 1/10, 2/10, 3/10, 4/10, 5/10. Same thing as if I just basically did this, right? So I get 5/10, and then I'm saying that that's exactly equal to, well, I guess I could, yeah, let's do it upside down. 1/2 like this. And you can see when I line them up properly that this is exactly equal to 1/2 the pizza. I can lift this up, put it over here, and that 5/10 is exactly equal to 1/2. So let's prove to ourselves. Let's pick this guy up. Let's put it over here. The 2/5, let's put it there. Let's put 1/10 and let's add the original fractions together, and you can see that actually it does exactly equal 1/2 of a pizza. So whenever you're adding fractions, okay, I am not able to visualize what the answer is going to be in my mind. So I kind of want you to forget about that. A lot of students get frustrated because they can't see the fractions and they don't know how they add. Like this plus this, I would never guess that it was 1/2. I wouldn't be able to figure that out. So I'm showing you by proving it to you, but I don't want you to try to predict. What I want you to do is say, all right, I need a common denominator. I'll multiply by 2. I now have a common denominator. Okay, that's the common denominator. Add the numerators together. Here's the answer. Simplify the answer. There's the final answer. Boom. And then after you do it enough times, you prove to yourself that it's always going to work correctly by showing you these examples. Okay? So let's back up the truck a little bit and do a few more examples and these are going to go a lot faster because I'm not going to use the models anymore. For instance, let's take a look at the fraction 3/10. I want to add to that the fraction 17/100. I don't have any models, or I can't draw a fraction with 100 slices of pizza and it's 17 out of 100. It's going to be very hard. But what I do know is that if I take this, I have a 10 and 100. If I take this and multiply by 10, 10 times 10 is 100, so I can get a common denominator. So what I'll do is I'll say 3/10. I can multiply top and bottom by 10. And so what I'm going to get is 3 times 10 is 30, and 10 times 10 is 100. I'm going to add to that 17 out of 100. And now I have the same denominator, 100. Denominator is 100, so I put that in my final answer, and then I add the numerators, 30 plus 17. And then I add this 30 plus 17. When you go and you can go off to the side, or you can add it on your fingers, it comes out to 47. And the denominator stays 100. And then you ask yourself, can I simplify this? Can I divide it, the top and bottom, by something to make it simpler? And you can't simplify it any further. This is fully simplified. So I don't want to say nobody can visualize it, but I don't know anybody that can look at 3/10 and visualize 17/100 and figure out that it's going to be 47/100 in your mind. You just can't. This, for a lot of people, is the first time in math where you just can't figure out the answer by looking at it, because we cannot visualize too many things in our mind at once. Okay, maybe you're one of those special people, but I can't do that. So I want you to use the method I'm showing you. Find a common denominator and so on. All right, next problem. Let's take a look at 6/10, and we'll add to that 27/100. Same exact problem. I have a 10 and a 100. So what I'll do is I'll just multiply this fraction by 10 on the top and 10 on the bottom. That way I'll have 100. So what I'm going to have is 6/10. And what I'll do is I'll multiply this guy by 10 on the top and by 10 on the bottom. What do I get? 60 on the top, and I get 100 on the bottom. So 60/100 is the same thing as 6 out of 10. I'm going to add to that 27/100. And so now I have my common denominator, which is all I really cared about. So in the answer, I'm going to have 100. In the numerator, 60 plus 27. 60 plus 27. 60 plus 27. Again, you can go off to the side and you can add that, or you can use your fingers. 60 plus 27 works out to be 87. when you add those, over 100. And then you ask yourself, can I simplify this? Can I divide 87 and 100 by the same number to make them both simpler? And actually you cannot. So this is the final answer. I cannot look at 6/10 and 27 100ths and just know that the answer is going to come out to this. I can't do it. So I don't want you to do that either. I want you to use the process here. All right, here is, we only have a few more of these problems. Here's problem number 6. Notice we're going a little bit faster. Once we aren't doing the models, everything gets a little faster. Let's take a look at 1/8, and we'll add that to 2/4. All right, so we have a 4 in the denominator, and we have an 8 in this denominator. So if I take this fraction and multiply by 2, 2 times 4 is 8, and so then I will get the same thing here. So I'll take the 2/4, and I'll multiply the top and the bottom by 2 and by 2. What will I get? 2 times 2 is 4 on the top. 4 times 2 is 8 on the bottom. I'm still adding 1/8 from before. I haven't changed that, and I'm going to add these two fractions. So now I have 8 and 8 for my common denominator, and then 1 plus 4. 1 plus 4 on the top, which becomes 5/8. That's the final answer. You can't simplify this anymore. I cannot divide the top and the bottom of this fraction by some other number to make it any simpler. All right, running out of board space. I think I have room on this last board to crank out. We'll go ahead and do the last few here. Let's take a look at 3/20ths, and we're going to add to that 1/10. So I have a 20 on the denominator and a 10. How do I get a common denominator? I can take this fraction and multiply by 2, 2 on the top and 2 on the bottom. 2 times 10 is 20, then it'll match. So here I have 1/10. And I'm going to multiply on the top and bottom. I'm going to multiply 2 and by 2. And so 1 times 2 is 2. And then 10 times 2 is 20. And I'm adding to that the 3/20ths. And I'm going to go ahead and add these fractions here. Now I have a 20 on the top and a 20 on the bottom. That's all I'm ever trying to do is get the same thing on the bottom. Then I have 20. And then I add 2, or 3 plus 2, which equals 5 out of 20. Can I simplify 5/20ths? Yeah, I can, because 5, 10, 15, 20, right? They're both divisible by 5. So what I can say is 5/20ths. I can divide the top and bottom by whatever I want. I know I can divide both by 5. 5 divided by 5 is 1. 20 divided by 5 is 4, because 4 times 5 is 20. And so the answer is 1/4. I don't have a set of magnets to cut into 20 that are cut into 20 pieces, so I can't show you this, but we've done enough of them for you to know that even though they look very different, if I actually sliced a pizza and put them together, it would actually work out to be 1/4 of a pizza in the final answer. All right, cranking right along, almost done. Let's take a look at 1/10, and we're going to add to that 53 100ths. All right, so we have, again, a 10 on the top here in the top fraction for the denominator and 100. So all I have to do is multiply this by 10. That would give me this guy. So I'll start out with the 1/10, and I'm going to multiply this by 10 by 10. On the top, I'll have 10. On the bottom, I'll have 100. So I now have a common denominator. I'm adding to that 53 over 100. And so how do I finish out the addition? I have the same denominator here, so that means that goes in my answer. Whoops, not a 5. Sorry about that. 100 in the bottom. 10 plus 53. And when you add 10 plus 53, what do you get? 63. 63 out of 100. Now this is the answer, but we ask ourselves, can we divide top and bottom by something to make this simpler? And we can't. So this is going to be the final answer. 63 out of 100 is already fully simplified. All right, only 2 more problems. Next problem is 3/8, and we're going to add to that 2/4. Can I find a common denominator? Well, I have an 8 and I have a 4. So if I take this 4 and multiply by 2, I will match this denominator. So I'm going to do that. I'll take the 2/4 and I'm going to multiply top and bottom by 2. And that's going to give me 2 times 2 is 4, and 4 times 2 is 8. So 4/8 is exactly the same as 2/4. Now I'm adding the 3/8 to it, and so I'm adding these guys together. Now this new fraction has the same, or these new fractions have the same denominator. So that means the denominator is going to have an 8 in there, and then 3 plus 4 goes on the top. 3 plus 4, which is 7, and then 8 goes on the bottom, and I can't simplify that any further. It's just 7/8. If I can't think of anything to divide top and bottom by to make that any simpler. All right, we're going to squeeze our last problem right here on the bottom here. We have 6/10, and we're going to add to that 19 100ths. Same song and dance. 10 and 100 are my denominators. If I multiply this one by 10, I'll match the 100 here. So what I'll have is 6/10, and I'm going to multiply on the top by 10 and on the bottom by also 10. 6 times 10 is 60, and 10 times 10 is 100. So this is my new fraction. Now I'm adding to it 19 100ths. And then I ask myself, okay, do I have a common denominator? Yes, I do. The common denominator is 100. So in my final answer, the denominator is definitely going to have 100 in it. 60 plus 19 goes in the numerator. 60 plus 19. And when you go off to the side and add 60 plus 19, you'll see that comes out to 79 and 100 on the bottom. Now this is the answer. You should always ask yourself, can you simplify this? Actually, in this case, you cannot. There's no way to divide the top and the bottom of this fraction by something, by the same number, to make those numbers both simpler. So this is already in lowest terms. So in the first few problems, we use the models to prove to you that when you have two fractions that look quite different, the answer you get, it doesn't seem obvious that you could start with 1/2 and 1/6, but the answer you get can be 2/3. So stop trying to visualize in your mind exactly how it works. I mean, you can draw pictures, that's great, but don't try to guess ahead of time because none of us is going to be able to do that. It works out that way, and we have a bulletproof way of doing it, but trying to visualize this and get it and figure out that the answer is 2/3 is very hard. I wouldn't try to do that. Just get your common denominator, get both fractions to have the same common denominator, add them together in the usual way, simplify the answer. I'd like you to practice these as much as you need to feel like you understand. And as we move through the lessons, we'll be going through subtraction and other ways to build your skills in fractions. Learn anything at mathandscience.com.